Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 13 video on the concept of limits, I will solve another 5 problems. This is set 4, which are based on the standard results of limits of trigonometric functions. As much as possible, I will try to use the standard results of trigonometric functions to solve the problem. But as you know that to solve there are various techniques and methods to solve problems on limits, and in most cases, especially for competitive examinations, you will have to apply multiple methods or concepts to solve a limiting problem. But still I will try to solve using purely the standard results of limits of trigonometric functions. So this video is part of the playlist Problematic Mathematics for class 11, where I primarily discuss about the key concepts and formulas for solving problems that comes in JEE Mains, JEE Advanced or WBJEE. If you find this video beneficial, then please like it, share it with your friends, and please support me to grow my channel. Subscribe to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so his first problem is limit x tending to 0 cos of sin x minus cos x divided by x to the power 4. Now I have already said multiple times in the previous videos that for solving limiting problems, whenever you see so the idea for if you see trigonometric functions and if you are targeting to solve the problem of limits using the standard results of trigonometric functions, then eventually you have to create factors of, eventually you have to simplify the entire given function as the factors of sin x by x, sin x by x, or tan x by x and cos x. Now instead of x, it could be any function of x. So and in doing that, there are certain trigonometric identities or formulas you must they are widely used. They are very useful for converting the given function as factors of sin x, cos x, or tan x. So one of them is, let me refer, since I am very weak in trigonometry, I do not remember the formulas, so I have to use the formula of cos A minus cos B. As in the problem, I can see the numerator is in the form of cos A minus cos B. So what is the formula of cos A minus cos B? This is equal to negative of twice sin x plus y by 2. Okay, so this is, I am referring the PDF of formulas, trigonometric identities and formulas on the left hand side. So limit x tending to 0, negative of twice of sin x plus y by 2. Now x over here is sin x and y is x. So sin x plus x by 2 multiplied by sin x minus y by 2, sin of sin x minus x by 2. Okay, and cos A minus cos B. Okay, divided by x to the power 4. So in the numerator I have two factors of function sin, and the arguments are sin x plus x by 2 and sin x minus x by 2. So definitely sin x plus x by 2 when x tending to 0, this whole thing, that is sin x plus x by 2 will tend to 0 when x tending to 0. Also this thing sin x minus x divided by 2 will tend to 0 when x is tending to 0. Okay, now so just for the sake of discussion and easiness of solving, let fx be the function sin x plus x by 2 and gx be the function sin x minus x by 2. So then this becomes obviously we see that as x tend to 0, both fx will tend to 0 and also we see gx will tend to 0. Okay, so the limiting problem becomes x tending to 0 minus twice sine of fx multiplied by sine of gx all divided by x to the power 4. Okay. Now I will create the standard form sin x by x, x tending to 0 minus 2 sin fx by fx, and then sin gx by gx. So I have introduced the fx and gx as in the denominators and I have to adjust them fx multiplied by gx divided by x to the power 4. Okay. Okay. Now since fx and gx are tending to 0 when x is tending to 0, then limiting value of sin of fx by fx will be 1 and also sin of gx by gx will be 1. So these two will be 1. So this now becomes limit x tending to 0 minus twice fx multiplied by gx divided by x to the power 4. This is, let's bring the minus to outside, limit x tending to 0 fx gx by x to the power 4. What is fx? Fx is sin x plus x by 2 and gx is sin x minus x by 2 and we have all divided by x to the power 4. Okay. Square. Sin x sin square x. Okay. This is minus 2 limit x tending to 0 using the formula a plus b into a minus b is a square minus b square. So this will be, let's bring the 1 by 4, let's factor out 1 by 4. So we have by 4 and we have sin x plus x multiplied by sin x minus x. So this is sin square x minus x square. We have divided by x to the power 4. X to the power 4. The answer is 1 by 6. Okay. Cos A minus cos B. Cos A minus cos B. Okay. So how to solve this now? X square. X square. So the idea is to definitely form the sin x by x or any power of sin x by x square square 1 0. 2 sin a plus b cos a minus cos b is minus twice sin a plus b by 2 sin x minus b by 2. Sin fx dx fx dx minus 2. Now possibly at this stage if we know the expansion series of sin x, probably it will be easier if we expand if we use the expansion series of sin x. Or you can also use L'Hopital's rule. So it is not so it is, I mean, it is a standard convention, that standard a strategy to use multiple concepts and methods to solving a limiting problem. So so far I manipulated the given function using trigonometric identities and formulas, so that I applied the concept of sin fx by fx when fx tends to 0 is 1. But now I could not. So at this stage, using that concept, I am not able to solve the problem completely. So at this stage I am stuck. I am not sure how further I will manipulate this sin square x minus x square divided by x to the power 4, so that I will get a finite limiting value using the formula result sin x by x tending to 0 is 1. Now if I at this stage, if I use L'Hopital's rules, let's see what do I get. Because sin square x minus x square will tend to 0 when x tends to 0. So this is of the form 0 by 0, and I can use L'Hopital rule. So it will be 2 sin x cos x minus twice x divided by 4 x cube. Let's cancel out 2 cancels out, and this is 2. Okay. So this is sin 2x by 2 minus x divided by twice x cube. It is again of the form 0 by 0. So I can further use L'Hopital's rule, and it will be sin 2x. Okay. So it will be cos 2x minus 1 divided by 6 x square. Okay. Again it is of the form, so you can apply L'Hopital's rules forever, as long as it is of the form 0 by 0 or infinity by infinity at the tending value of the variable. So cos 2x minus 1 when x tends to 0 will be again 0, and 6 x square is also 0. So this is also again of the form 0 by 0. If I further differentiate, if I further apply the L'Hopital's rule, it will be minus 2 sin x by 12x. Differentiation of cos x is minus sin x. So differentiation of cos 2x will be minus sin 2x into 2. Okay, which is minus sine 2x by 6x. So this is again of the form 0 by 0, and probably applying L'Hopital's rules one more time, we will be able to get the result. So if I differentiate this once more time, that is apply L'Hopital's rule one more time, I am really sorry for my congested solution, I will get. So I have minus sine 2x divided by 6x. Okay. And then I will have minus 2 cos 2x divided by 6. This is minus cos 2x by 3. Now cos 2x will tend to 1 when x tends to 0. So it will be minus 1 by 3. Minus 1 by 3. Minus 1 by 3, and outside the limit we have minus half. So minus half, this is half, so minus half multiplied by minus 1 by 3 is equal to 1 by 6. So it is extremely normal that you apply multiple concepts, mixed concepts and methods to solve a limiting problem. That is, there are various ways, L'Hopital's rules, using expansion series, rationalization method, and then standard results. All these concepts you have to apply. All these multiple concepts you have to apply to solve a limiting problem, especially that comes in the competitive examinations. Okay. So this so always try to, so there are certain formulas. I will probably make another video where the most important trigonometric identities and formulas can be used very fruitfully in solving limiting problems, where the given function is where the given problem involves trigonometric functions. It may not so using and you can apply the standard results of trigonometric functions. It may not solve the problem completely, but at least you can progress to some extent. Okay, let's see the next problem. Now this one, if limit x tending to 0, x by we have 1 minus sin x whole to the power 1 by 8 minus 1 plus sin x whole to the power 1 by 8. Now if you try to manipulate this the denominator, especially denominator, using trigonometric identities and formulas, so that you will create the standard form of sin x by x or maybe tan x by x. Maybe it is possible, I don't know, I couldn't do it. Maybe it is possible, but a much more easier way is to use the expansion series. This expansion, that is 1 plus x whole to the power n, where n is a rational number. Q, the letter Q stands for the set of rational numbers, and x is where mod x is a real value, real number, but mod x is less than 1. For this, then this can be the expansion series is 1 plus nx by 1 factorial plus n into n minus 1 x square by 2 factorial plus n into n minus 1 into n minus 2 x cube by 3 factorial, and so on. This is an infinite series. Okay. Now why it will be useful? Because you see, we have in the given problem, in the denominator, we have something like this. The x in the given problem is actually sin x. So we have something like this, 1 minus x, and the n is 1 by 8 in the given problem. We have something like this. Now if you what will be the result of 1 minus x whole to the power n minus of if you subtract 1 plus x whole to the power n from 1 minus x whole to the power n, what will be the result? So this is okay. So this is 1 minus remember in the formula 1 plus, in the expansion series of 1 plus x whole to the power n, you can also find the result of 1 minus x whole to the power n if you replace x with minus x. So 1 minus x whole to the power n will be 1 minus, just replace x with minus x, 1 minus nx plus n into n minus 1 x square by 2 factorial, and then I will have minus n into n minus 1 n minus 2 x cube 3 factorial, and then it will be plus this thing, and then negative minus 1 plus x whole to the power n. It will be 1 plus nx plus n into n minus 1 x square by 2 factorial plus n into n minus 1 n minus 2 x cube by 3 factorial, and so on. So you can see a lot of the terms from both the expansion series will cancel out, like all the let me see, minus nx. Okay, so all the even powers of x will cancel out, and all the even powers of x will cancel out. Also 1 will cancel out. So this is actually, this will be 1 will cancel out. So this will be minus of twice 2 into nx, and then plus all the odd powers of x will remain. Okay, minus, so this will be n minus 1 n minus 2 x cube by 3 factorial, and then we will have like this. Now okay, okay, now in the given problem, instead of x in the denominator, if I, so what will be the denominator in the given problem? It will be limit x tending to 0 x by, we will have minus of twice, we will have nx. X in the given problem is sin x, and n is 1 by 8. So it will be 1 by 8 sin x plus 1 by 8 into n into n minus 1 into n minus 2. Okay, let's write n only, and then finally I will replace n with 1 by 8. Okay, so we have, so it will be minus twice nx, n sin x, n sin x, y sin x, 1 minus sin x. Yes, it will be x is sin x. Okay, let's see, nx, so nx plus, and then n into n minus 1 into n minus 2. Remember n, I am writing n, but actually it will be 1 by 8. Then sin cube x divided by 3 factorial, like this. Okay, now let's bring the x from the numerator. So this is first of all, let's bring the minus half. Let's factor out minus half. So this is minus half limit x tending to 0. Okay. So this will be, if I bring the x from the numerator downwards to the denominator, it will be n sin x by x, and then it will be n minus 1, n minus 2 divided by 3 factorial, okay, and then sin x by x multiplied by sin square x. Now clearly you can see that in the denominator all the terms sin x by x, the limiting value of sin x by x will be 1, but we will have the second term is having a factor of sin square x. The third term will have a factor of, apart from sin x by x, it will have a factor of sin x to the power 4. So all those factors will be 0 because x is tending to 0. So clearly then the limiting value will become minus half multiplied by 1 by n. So this is equal to what is n? N is so this is minus half multiplied by what is n? N is 1 by 8. So this is equal to minus 4. The answer should be minus 4. Oh yes. So this expansion series 1 plus x to the whole to the power n, where n is a rational number and x is a real number, such that mod of x is less than 1 is equal to 1 plus nx by factorial 1 plus n into n minus 1 into x square by 2 factorial. This way you can use this expansion series. Using this, it will be super easy to solve this particular problem. Okay, let's see the next problem. Okay, so fx is given as a function. If the function fx is a box of sin x by x plus box of 2 sin 2x by x up to a box of 10 sin 10x by x. Now, and we have to find the limiting value of fx when x tending to 0. I discussed one concept while discussing the standard trigonometric standard results of limits of trigonometric functions of sin x by x, that this concept you must always remember, that when fx, whatever the tending value, let's say fx is a real valued function of x, and whatever the tending value of x is given in the limiting problem, if at that tending value of x, fx tends to 0, this is in short written as fx tending to 0. So if fx tends to 0 implies that sin of fx by fx, this will tend to 1 minus, that is the actual value of sin fx by fx will be a little less than 1. But we know that of course the limiting value sin of fx by fx when fx tending to 0 is of course equals to 1. But the actual value of sin fx by fx will tend to the value which is little less than 1. This thing you must always remember. This concept will be used to solve this problem. So we can see that x tending to 0 implies, we know that implies that sin x by x will tend to 1 negative. Okay, again 2 sin 2x by x, 2 sin 2x by x, and this implies when we have sin x by x is tending to 1 negative, then box of sin x by x will be actually equal to box of 1 negative, which is equal to 0. Okay, now let's see the second term, twice sin 2x by x. The concept is that I will this is equal to twice I will create I will create the form sin x by x. So I will have sin 2x and then I will multiply. So this is 4 sin 2x by 2x. 2 sin 2x by x can be written as 4 sin 2x by 2x. Now when x tends to 0 implies that 4 sin 2x by 2x will tend to a value which is 4 multiplied by sin 2x by 2x will tend to 1 minus. So definitely I don't know whether this is I am mathematically writing it correctly or not. 4 multiplied by 1 negative 1 minus. 1 minus is the tending value of sin 2x by 2x when x tending to 0. So this is actually 4 minus. So 4 into sin 2x by 2x will tend to a value which will be little less than 4. Similarly, you have to find for all the given terms. So the first term, the first result, the first term is becoming 0. The first term is becoming 0. The second term is becoming okay. Then this will implies that box of 4 sin 2x by 2x will be equal to box of 4 minus, which is equal to 3, okay. So what will be the third term? The third term is definitely 3 into sin 3x by x. So 3 into sin 3x by x can be rewritten as 9 into sin 3x by 3x. Now x tending to 0 will imply that 9 sin 3x by 3x will tend to 9 minus. That is, since sin 3x and 3x, sin 3x by 3x when x tending to 0, the value of sin 3x by 3x will tend to 1 minus. Then 9 into obviously 9 into sin 3x by 3x will tend to a value which will be a little less than 9. One second, friend, I will, my laptop is almost discharged. Let me quickly plug in the charger. Okay, so this is tending to 9 minus. Okay, so this implies that box of 9 sin 3x by 3x will be equal to box of 9 minus actually I should write not equals to box of this should be 10 to, and this is 10 to, and now I can say this is 8. Okay, so the third term is exactly equal to 8. The second term is exactly equal to 3, and the first term was exactly equal to 0. So this way all the terms will have some exact values. Okay, do we see any pattern? 0, 3, 8, 0, 3, 8. I don't know. Let's see. Okay, let's try to see. Okay, I think I should in this way it will be very tedious. So what is the nth term? So we have 10 terms. Fx is basically, what is fx? Fx is basically, let's say, summation of Tn, n, not Tn but Ti Ti, where I is 1 to n. And where Ti, what is Ti? Ti is what is Ti? Ti is, or let's say let's use K. So T, K, kth term, K equals to 1 to n. So not 1 to n, but 10. Since there are 10 terms, box of sin x by x, box of 2 sin 2x by x, up to box of 10 sin 10x by x. So Tk is k into sine of kx by x. Okay, this is the kth term. So what will be, so when x tending to 0, okay, so this is equal to, I can say k, so this is k square sine kx by kx. So when x tending to 0, this will imply k square sine kx by kx. This will tend to, obviously this will tend to k square multiplied by 1 minus, because when x tending to 0, sin kx by kx, where k is some natural number from 1 to n, will obviously be will tend to a value which is 1 minus, that is a value little less than 1. Now what will be k square multiplied by a value which is little less than 1, little less than 1. Obviously this this is equal to k square minus 1. Is it so? K square multiplied by 1 minus is equal to k square minus 1. I think I am right, like 3, okay, anything multiplied by, yeah, it's fine. So we have this, sorry what I am doing. So this is this. So this implies that box of k square sin kx by kx will tend to a box of k square multiplied by 1 minus, which will be exactly equal to k square minus 1. So then let me make some space. So then what will be the value? So then what is fx? So okay, so then limit x tending to 0, fx is becoming equal to the kth term, when the kth term of the fx, when x is tending to 0 is becoming exactly equal to k square minus 1. So this will be summation of k square minus 1, where k is 1 to 10. Okay, so this is summation of k square, k 1 to 10 minus summation of k 1 to 10 1. So this is summation of square of the natural numbers, first 10 natural numbers. Summation sigma k square, k 1 to 10 means the sum of the first 10 natural the sum of the squares of the first 10 natural numbers, whose formula is what is the formula? Okay, so k n into n plus 1 into 2n plus 1 by 6. So n into n plus 1 plus 2n plus 1 divided by 6, and this is minus 10. Okay, this is 21 11. So 21 multiplied by 11 multiplied by 10 by 6, 10 by 6 minus 10. This is equal to 3 2 3 7 2 2 5 55. 77 multiplied by 5 is 35. 385 minus 10, which is equal to 375. I think the answer is 375. Yes, 375. So this problem was a little conceptual. The concept is that when fx tends to 0, sine of fx by fx always tends to 1 minus. Also, in this regard, tan fx by fx will tend to 1 positive. Always remember these two concepts. Let's see. Okay, let's see. I will solve only the question number 4. So what is this? Limit x tends to 0. 6x square multiplied by cot x multiplied by cosec 2x divided by sec of cos x plus pi tan pi by 4 sec x minus 1. Let's see. First, it is very important that you have to first substitute the tending value and see what form it is taking. Okay, clearly what if I consider this to be gx, the argument to sec in the denominator, let's say that argument is I am denoting by the function gx. So when x is tending to 0, gx, what will be the tending value of gx? Cos x will be tending to 0. It will be 0 plus tan of pi into tan of pi by 4 sec x. Now sec x will tend to, sorry, cos x will tend to 1. Now cos x will tend to 1, not 0. This will be 1. Okay, and cos x 1. Okay, so sec x will also tend to 1, and then tan of pi by 4 will tend to 1. So this will be pi minus 1, which is tending to pi, pi. So gx, that is the argument to sec in the denominator, is tending to pi. So this implies that sec of gx is tending to sec of pi, which is cos of pi is minus 1, tending to minus 1. Okay, so in the given problem, the denominator is tending to the value minus 1. So we can clearly bring that outside the limit. So this is equal to minus of limit x tending to 0, and we have 6x square. Cot x is by tan x multiplied by 1 by sine 2x. Okay, so this is negative of limit x tending to 0. Okay, so it's easy. Let's bring the 6 outside, minus 6, and we can let's distribute the x square from the numerator as 1 to the denominator of tan x and 1 to the denominator to sine 2x. Tan x by x multiplied by sine 2x by x. Okay. Now limiting value of tan x by x when x tends to 0 is 1, but we have to simplify or sine 2x by x. Remember, so I have to the standard result is sine fx by fx. If x tends to 0 is 1. So I have to have 2x as a denominator to sine 2x. So if I do 2x and then adjust to, this will be this. So now this becomes limiting value of sine 2x by 2x when x tends to 0 is 1, and also limiting value of tan x by x when x tends to 0 is 1. So this becomes minus 6 multiplied by 1 by 1 multiplied by 1 multiplied by 2. This is minus 3. The answer should be minus 3. Yes. So that is all for this video. I hope solving this video will give you some insight, some clarity, conceptual clarity of how to solve this kind of problem based on the standard results of limits of trigonometric functions. Even though in solving some problem I used the expansion series 1 plus x whole to the power n, where x is mod of x is less than 1 and n is a rational number. And of course, if your concept of you must be very well aware and familiar with all the standard trigonometric ratios and identities. Some special identities will be extensively used and will be very useful in simplifying the given problem, so that you can have factors of sin x and tan x to apply the standard result of sin fx by fx and tan fx by fx. So if this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So I will solve in the next video, I will solve another set of 5 problems. Definitely it will not be the case that the entire problem will be solved only using the standard results of standard results of limits of trigonometric functions, but some other concept might also be used. So that is all for this video. I am ending the video here. Thanks for watching, and until the next video, take care and bye.